Enterprise AI often looks impressive in demos, then falls apart the moment real production demands show up. That matters to you because weak production discipline does not just waste technical effort, it damages trust, creates political friction, and makes future AI projects harder to get approved. In this video, I will show you why enterprise AI so often stalls between prototype and production, and what has to be defined earlier if you want systems that can survive real business use. This is where serious AI delivery stops being a demo exercise and starts becoming engineering. Part 1. Why prototypes look successful while real systems struggle. A prototype can look far more successful than the underlying system really is. That is one of the biggest traps in enterprise AI. The demo works in a controlled environment. The data set is cleaner. The prompts are adjusted by hand. The workflow is narrower. The person presenting it already knows what success is supposed to look like. Under those conditions, the output can seem impressive enough to create excitement across the organization. But a production environment is very different. Production means inconsistent inputs, edge cases, timing issues, user behavior, security boundaries, workflow interruptions, change requests, and support expectations. In other words, production introduces reality. That is why many AI initiatives look strong in a meeting, but become unstable when teams try to operationalize them. The prototype did not fail because it was useless. It failed because it never proved it could survive the conditions that matter most. A demo is not a system. It is evidence that something may be possible. That is a very different claim. When organizations confuse those two ideas, they begin treating a narrow success as though it already represents a deployable business capability. That creates false urgency, weak planning, and unrealistic expectations for technical teams. Prototypes survive because they are protected. Systems fail because they are exposed. That distinction matters. A prototype often depends on hidden manual support, informal judgment, and limited scope. A real system has to stand up under repeat use, changing conditions, and accountability across multiple teams. The practical lesson is simple. Do not evaluate a prototype only by how impressive the output looks. Evaluate it by what has been intentionally excluded. Ask what assumptions made the demo succeed. Ask what manual support is hiding in the background. Ask what happens when the workflow becomes messy, the data becomes inconsistent, and the business expects reliability. That is where production reality begins. Part 2. The common mistake: confusing a prototype with a production candidate. One of the most expensive mistakes in enterprise AI is treating a prototype as though it is already a production candidate. That usually happens because the visible part of the project gets most of the attention. People see a working interface, they see an impressive answer, they see a task completed faster than before. What they do not see is everything required to make that capability dependable, governable, and supportable over time. A prototype is built to learn. A production candidate is built to survive scrutiny. Those are not the same goal. If a system has no observability, no support ownership, no fallback behavior, and no change control, it is not ready for production conversation, no matter how good the output appears in a controlled setting. The missing pieces are not paperwork. They are the engineering conditions that determine whether the system can be trusted when something goes wrong. If nobody knows who supports the system is not production ready. If nobody can inspect failures, the system is not production ready. If there is no clear response when output is wrong, delayed, blocked, or unsafe, the system is not production ready. Project managers, infrastructure teams, security teams, and technical leads all experience this problem differently. The project manager sees unstable scope. Infrastructure sees operational uncertainty. Security sees unclear boundaries. The technical lead sees a capability that may work in principle, but lacks the surrounding controls needed for responsible deployment. Each group is reacting to the same underlying issue. The organization is trying to promote a learning artifact into a business system too early. A better discipline is to label work honestly. Call something a prototype when it is still proving feasibility. Call it an minimally viable product only when it has defined boundaries and controlled real use. Call it a production candidate only when the operational expectations are explicit. That honesty reduces confusion, lowers political friction, and gives delivery teams a more defensible path forward. The issue is not whether a prototype is valuable. It often is. The issue is whether the organization is pretending it has already crossed a line that engineering reality says it has not. Part 3. Define production criteria before the build goes too far. One of the best ways to prevent enterprise AI from stalling later is to define production criteria much earlier than most teams expect. Many groups wait until the prototype looks promising before they start asking operational questions. That feels efficient in the beginning, but it creates expensive rework later. Once people become emotionally attached to a demo, they often resist the engineering discipline required to turn it into something durable. Production criteria do not need to begin as a giant standards document. They can start as a short set of practical expectations. What logs will exist? Who supports the system? What is the review path for questionable output? How are failures handled? When does escalation occur? What should users expect from the system, and what should they never assume? Those questions are not administrative overhead. They shape the design itself. If production criteria are defined late, design mistakes get baked in early. That is why teams suddenly discover they need auditability, stronger access control, better exception handling, clearer ownership, or safer workflow boundaries after they have already invested heavily in the wrong structure. Defining criteria early does not mean every project must be over-engineered on day one. It means the team understands what graduation would require before the solution becomes politically popular. That changes how prototypes are built. It affects how prompts are stored, how user actions are recorded, how handoffs are handled, and how business review fits into the workflow. Even small early choices can either reduce or expand later rework. A simple rule helps here. Before building too much, define what good enough for real business use would actually mean. Not in abstract language, in operational language. What must be visible? What must be controlled? What must be recoverable? What must be owned? Those answers create direction for engineering, not just governance. The teams that move best into production are not always the teams with the most exciting prototypes. They are often the teams that define the finish line early enough to avoid fooling themselves. That is what production criteria really do. They protect momentum by giving it structure. Part 4. The model is usually not the hardest part of the system. One of the most useful contrarian truths in enterprise AI is that the model is usually not the hardest part. The model matters, of course. Its capabilities matter, its limits matter, its cost, latency, and behavior matter. But once a prototype shows that the model can do something interesting, the harder work often shifts somewhere else. It shifts into integration, workflow fit, ownership, supportability, and governance. That is where many organizations get surprised. They spend large amounts of energy debating model options, tuning prompts, and optimizing outputs, while underestimating the effort required to make the capability fit the real business environment. Can it connect to the right systems? Can it work inside the existing workflow without creating confusion? Is there a human review path when confidence is low? Does the business owner understand the limits? Does security know where risk enters the process? Those questions often determine success more than small gains in model quality. A technically impressive model wrapped in weak operational design is still a weak enterprise solution. That is why good AI delivery is not just model work, it is systems work. For programmers, this means the problem is broader than prompt quality. For DevOps, It means the deployment surface and operational signals matter. For infrastructure and security teams, it means governance has to be designed into the implementation path, not attached after the fact. For project managers, it means the plan has to account for dependencies that do not show up in the demo. When leaders accept that the model is not the hardest part, project conversations improve. Teams stop acting as though solving the output problem automatically solves the business problem. They start asking better questions about system fit, handoffs, exception handling, support roles, and production responsibilities. That shift is healthy because it turns AI from a novelty discussion into an engineering discussion. Mature enterprise teams do not win by finding the most interesting model behavior. They win by building a controlled operational environment around useful model behavior. That is the real challenge. And it is also where stronger competitive advantage tends to come from. Part 5. Prototype, MVP, and production are different construction states. Prototype, minimally viable product, and production are not just different labels for the same solution at different levels of polish. They are different construction states. Each state exists for a different purpose, carries different expectations, and justifies different engineering decisions. When organizations blur those distinctions, they create unnecessary tension between speed and discipline. A prototype exists to answer feasibility questions. Can this approach work at all? Can the model produce useful output? Is the workflow even a candidate for improvement? Do the functions we need exist and work as expected? The prototype is about learning. A minimally viable product, or MVP, is different. It is not just a prettier prototype. It is an intentionally bounded version of a real capability designed for controlled use with clearer operational expectations. Production is different again. Production means the system is expected to behave reliably, be supportable, fit within governance boundaries, and survive ongoing change. Each state deserves different engineering treatment. A prototype can tolerate shortcuts that would be unacceptable in production. An MVP must begin proving operational behavior. Production must carry explicit accountability. This matters because teams often try to move directly from prototype enthusiasm to production expectations without acknowledging the middle transition. They skip the part where boundaries get clarified, support expectations get defined, and operational signals become visible. Then they wonder why the system feels unstable. It feels unstable because the organization is demanding production trust from something that was still built as a learning artifact. A practical discipline is to define the purpose of each state in writing. What is this phase supposed to prove? What is intentionally out of scope? What has to become true before the next phase is justified? That keeps conversations grounded. It also helps executives and department heads understand that progression is not just about spending more money. It is about changing the engineering contract around the solution. Once teams start treating prototype, MVP, and production as distinct construction states, planning improves. Expectations improve. Escalation improves. Delivery becomes more honest. And honesty is essential here because enterprise AI fails faster when organizations pretend a phase transition has happened before the engineering evidence says it has. Part 6. If there is no logging, there is no trust. In enterprise AI, no logging means no trust. That may sound blunt, but it is operationally accurate. If a system produces a questionable answer, fails silently, responds too slowly, or behaves inconsistently, the team has to be able to inspect what happened. Without that visibility, support becomes guesswork, governance becomes weak, and business confidence begins to erode. The system may still function sometimes, but it cannot be responsibly operated. Logging in AI systems is broader than traditional application logging. Teams often need visibility into prompts, inputs, outputs, exceptions, latency, retries, workflow state, human overrides, and the context in which decisions were made. Not every organization will log every detail in the same way, and privacy or compliance constraints may shape what is appropriate. But the core principle remains the same. If you cannot inspect behavior, you cannot manage behavior. You cannot support what you cannot see. That is the production truth. When an executive asks why a result was wrong, when security asks what happened during an incident, or when a user says the system failed in a specific case, the team needs more than opinion. It needs evidence. Logging also changes team behavior in a positive way. It forces design clarity. It makes engineers think about failure paths. It makes project managers take escalation more seriously. It gives reviewers a basis for discussing risk and performance without relying on memory or anecdotes. In other words, it transforms AI from a mysterious capability into an inspectable business system. If a team is building an AI feature and logging is treated as optional, that is a warning sign. It usually means the project is still being thought of as a demo, even if people are speaking about it as a deployment candidate. Production trust requires the ability to explain what happened, not just react to what happened. Logging is not glamorous. Users rarely celebrate it. Executives rarely ask for it first. But it is one of the clearest dividing lines between AI that looks impressive in a meeting and AI that can be defended, supported, and improved in the real world. That is why no logging ultimately means no trust. Part 7. Define promotion gates before the initiative becomes popular. One of the most practical actions an organization can take is to define MVP and production promotion gates before the AI initiative becomes politically popular. Once a demo attracts excitement, the pressure to move fast usually increases. People want timelines, wider rollout, budget discussion, and visible progress. If the gates are not already defined, that pressure can push teams into premature commitments. A promotion gate is simply a clear statement of what must be true before a solution advances. For example, before moving from prototype to MVP, the initiative may need a defined workflow, a named business owner, clearer data boundaries, and an agreed review path. Before moving from MVP to production, it may need stronger logging, support ownership, fallback handling, security review, performance thresholds, and operational sign-off. The exact criteria will vary, but the principle is consistent. Advancement should be earned, not assumed. If the system cannot meet the gate, it has not failed. It has revealed what still needs to be true. That is a healthy outcome. What becomes unhealthy is pretending the missing conditions do not matter because the demo was persuasive. Promotion gates help every role involved. Project managers gain a cleaner framework for planning. Technical leads gain cover for asking hard questions. Security and infrastructure teams gain a more orderly review process. Executives gain a more realistic portfolio view. The entire organization benefits because expectations stop drifting. Keep the gates simple enough to use. They should not become ceremonial paperwork. They should function as a shared decision tool. What has been proven? What remains unresolved? What risk is still open? Who is responsible if something breaks? Those are the kinds of questions that keep AI initiatives honest while momentum is still manageable. The organizations that scale AI more effectively are not the ones that move every promising demo into broad rollout. They are the ones that know how to say, "Not yet, these conditions still matter." That is not bureaucracy. It is disciplined progress. And in enterprise AI, disciplined progress usually outperforms rushed enthusiasm. Enterprise AI fails in production when organizations mistake promising output for production readiness. The teams that win will define clearer gates, stronger operational expectations, and more disciplined engineering around their AI systems. Explore more of my work at ain.net.com. Thanks for watching.